The conversation around electric vehicle batteries has quietly shifted over the last year, not with flashy unveilings or sudden announcements, but through production lines, supplier contracts, factory layouts, and subtle changes in how companies talk about scale. By 2026, batteries are no longer just a component of electric vehicles. They are the strategic center of the entire auto industry. And when we look closely at what production lines are telling us right now, a much clearer picture emerges of where Tesla stands, where its competitors are catching up, and where the next real breakthroughs may actually come from. Tesla's battery strategy in 2026 is no longer experimental. The era of testing concepts is mostly over. What matters now is yield, consistency, cost per kilowatt-hour, and how fast those batteries can move from raw material to installed vehicle. The 4680 battery cell, once treated as a moonshot, is now better understood as a long-term industrial bet. Tesla didn't design it to win headlines. They designed it to win manufacturing economics. Larger format cells reduce the number of welds, simplify pack design, and integrate directly into vehicle structure. But the real story in 2026 is not the cell itself. It's the production philosophy behind it. Tesla's production lines increasingly resemble something closer to a semiconductor fab than a traditional auto plant. Automation density is higher, human intervention is lower, and quality control is embedded directly into the line instead of being checked afterward. This matters because battery performance gains today are incremental. A 5% increase in energy density or a 7% reduction in cost doesn't come from a new chemistry alone. It comes from thousands of micro-optimizations across the production process. What's telling is how Tesla has slowed down public battery hype while quietly expanding capacity. Giga Texas and Giga Nevada continue refining dry electrode techniques, even if full-scale dry electrode dominance hasn't arrived yet. The lesson here is important. Tesla isn't betting on a single breakthrough year. They're betting on compound improvement over a decade. That's why their production lines emphasize flexibility. They can adjust cathode chemistry, tweak silicon content, or modify pack architecture without rebuilding the entire factory. Now compare that to what competitors are doing. Legacy automakers, especially in North America and Europe, are still largely dependent on suppliers. Their production lines are modular but not deeply integrated. A battery factory may sit next to a vehicle plant, but the data systems, control software, and iteration loops often remain separate. That separation costs time, money, and learning speed. However, 2026 marks the point where some competitors finally begin to close that gap. Companies like BYD, CATL-backed partners, and Hyundai Kia are no longer just battery buyers. They're becoming battery operators. BYD's Blade battery production is particularly revealing. Instead of chasing maximum energy density, BYD prioritized safety, simplicity, and thermal stability. Their production lines reflect that philosophy. Fewer variations, fewer SKUs, fewer changes. This makes scaling easier and margins more predictable. CATL, meanwhile, plays a different game entirely. They are not trying to beat Tesla at vehicle integration. They're trying to become the default battery infrastructure for the world. In 2026, CATL's production lines show extreme adaptability. They can pivot between LFP, sodium-ion, and hybrid chemistries faster than most automakers can redesign a bumper. This flexibility gives CATL enormous leverage. Automakers that rely on them inherit that adaptability, but also that dependence. One of the most under-discussed developments in 2026 is sodium-ion batteries. They are not replacing lithium-ion for long-range vehicles yet, but their production lines are simpler, cheaper, and less constrained by raw material supply. What production tells us is that sodium-ion is no longer a lab experiment. It's entering early mass production for entry-level vehicles, grid storage, and urban fleets. Tesla has not publicly embraced sodium-ion for cars, but their energy division is watching closely. And competitors in China are moving faster here because they can tolerate lower margins in exchange for volume dominance. Another major signal from production lines is where solid-state batteries actually stand. Despite the headlines, solid-state is not arriving in mass-market vehicles in 2026. What is arriving are semi-solid and hybrid designs that improve safety and energy density without completely reinventing the manufacturing process. Toyota, BMW, and several startups are learning a hard lesson. A battery that works in a lab is meaningless if it can't be produced at scale with acceptable yield. Tesla's apparent lack of solid-state hype is not accidental. Their production philosophy favors evolutionary manufacturing over revolutionary chemistry. If a new battery requires entirely new equipment, new supply chains, and new failure modes, Tesla is cautious. That doesn't mean they're behind. It means they're unwilling to sacrifice scaling speed for theoretical advantage. Production lines also reveal how battery cost curves are flattening. In the early EV era, costs dropped dramatically year over year. By 2026, those declines are slower. The low-hanging fruit is gone. What remains are operational efficiencies, recycling integration, and vertical supply control. Tesla's closed-loop recycling systems, combined with in-house cathode processing, reduce exposure to commodity price swings. Competitors are racing to replicate this, but few have matched Tesla's integration depth. Another critical insight from production is energy throughput per square meter of factory floor. Tesla's structural pack approach allows higher vehicle output per unit of space. That matters in a world where factory construction costs are rising. BYD counters this with simpler vehicle architectures and lower labor costs. European manufacturers struggle here because of regulatory overhead and energy prices. The production lines don't lie. Efficiency at scale favors those who designed factories around batteries from day one. We also see a shift in how automakers think about range. The obsession with maximum range is fading. Production data shows more emphasis on charging speed, cycle life, and degradation control. Tesla's newer packs prioritize maintaining consistent performance over hundreds of thousands of kilometers. This is partly software-driven, partly chemistry-driven, and partly production-driven. Uniformity matters more than peak specs. Competitors are learning this lesson too. Hyundai's eGMP platform improvements, Volkswagen's unified cell strategy, and GM's Ultium refinements all point toward simplification. Fewer cell formats, fewer pack designs, fewer exceptions. This is not glamorous, but it's how real scale happens. One of the biggest competitive threats to Tesla in 2026 doesn't come from a single automaker. It comes from ecosystems. Chinese manufacturers integrate batteries, motors, software, and supply chains in a way Western companies still struggle to match. Their production lines are shorter, faster, and more adaptable. Tesla counters this with automation and software intelligence, but the pressure is real. At the same time, Tesla retains a key advantage: learning speed. Every vehicle produced feeds data back into battery management algorithms. Production lines evolve based on real-world usage, not theoretical assumptions. This feedback loop is extremely hard to copy. Competitors can buy cells, they can license designs, but they can't easily replicate millions of vehicles acting as rolling test platforms. Looking forward, production lines suggest that the next major leap won't be a single chemistry breakthrough. It will be convergence. Better thermal management, smarter software limits, incremental material gains, and manufacturing refinements layered together. Tesla understands this. So do the best of their competitors. By 2026, the EV battery race is no longer about who announces the boldest future. It's about who quietly builds the most batteries with the least waste at the lowest cost, while improving just enough every year to stay ahead. Production lines tell that story far more honestly than press releases ever could. And if there's one clear takeaway from what those production lines are telling us right now, it's this. The companies that win the battery race will not be the ones with the most ambitious promises. They will be the ones who treat batteries not as miracles, but as machines. Machines that can be refined, scaled, repeated, and improved relentlessly. That mindset, more than any single technology, is what defines leadership in the battery era of 2026.